All right, today we're going to be talking about inverse functions and the relations. What I'd like you to do right now is you're going to make a little coordinate grid right here. I've given us some ordered pairs to plot. We're going to go ahead and plot those ordered pairs right now. We're going to go -4, 1, that right there. -2, +2, put it right there. 1 and a 3. 3 and a 4. And 4 and a 5. So these are just ordered pairs. Any ordered pair is a relation. Okay? Any ordered pair is considered to be a relation. So let's just call this A, comma, B. The inverse of all of these ordered pairs is simply going to be B, comma, A. So if we start with a -4, 1, we need to write a 1, a -4, a 2, and a -2, a 3, and a 1, a 4, and a 3, and a what? 5, and a 4. These are all the inverse relationships. All you do is you just simply switch your x and your y values. That's what an inverse is when you're dealing with ordered pairs or relations. So let's go ahead and plot these and see what we have. We have a 1 and a -1, 2, 3, 4. All right, we have a 2 and a -2. Okay. We've got a 3 and a 1 right here. 4 and a 3. And finally, a 5 and a 4. Now, there's something interesting about all of their inverse relationships and a special line called y equals x. All right, so I want you guys to write. Ready? We'll see. Bless you. All right, inverse relations. Okay? Inverse relations and functions reflect across, wait for it, y equals x. Now, we're going to draw y equals x on the page. Okay? Here we go. Here's the graph of y equals x. We'll do it in this color right. We'll start right here, straight down through the x-axis. This is the line y equals x, right there. So I want you to look. See how these points right here perfectly are reflected across y equals x? Same distance, right? 1, 2, 1, 2, 1, 2 and a half. 1, 2 and a half. If you were to go perpendicular, what I'm talking about. If you're not sure what I'm talking about, maybe I'll draw some lines. You guys can see the exact same distance. I'll do it in blue. See how those reflect perfectly across y equals x. The same distance. Perfect symmetry right there. All right, perfect symmetry. That's what I want you guys to understand. When you're asking to find inverse relations in their functions, what should the inverse function reflect across? Y equals x. What should the ordered pairs reflect across? Y equals x. So let's look at your first set of ordered pairs. All right? When it says find the inverse of each relation, everybody should be able to get the first 4 problems right. They're very easy. The inverse is simply 3, 0, 2, 4, and -6, 5. This set of ordered pairs, right here, underneath it is considered the inverse of it. That's all you have to do. 4 ordered pairs, yeah. First 4 problems should take you less than 60 seconds if you just simply switch the x and the y. All right, here we go. We're going to go to problem number 5. So problem number 5 in your journal. Number 5 asks you to find the inverse of each function. Well, the first thing I want you to understand is my final answer is going to be written like this. F to the -1 of x. That is the inverse of f of x. So whenever you see f to the negative 1 of x, that's referring to the inverse. So our final answer will be written as f to the negative 1 of x. Okay? Now, right here, this is f of x, which is simply saying what? Y equals 2/3 of x minus 1. So we're going to go over a step-by-step process of how to find the inverse of a function. So here we go. Step number 1. All I want you to do is to exchange. If you like the word switch, you can put the word switch. But that makes me think of something when I was a kid and I did something wrong and mom said, go pick up switch. So exchange or switch your x and y values or variables. So right here, instead of y equals 2/3 x minus 1, what I'm going to write x equals 2/3 y minus 1. So what did I do? I simply switched places with the x and the y. You guys remember doing that with the ordered pairs? You switch the x and the y ordered pair. We're doing the same thing with the variables here. We're switching x and y. Next thing I'm going to do is I'm going to choose a different color. Go green. Could you please just let me teach you this? Just as step 1, just exchange the x and the y. Just trust me, it's going to work. All right. It's a good question. Sorry I had to shoot you down. Now, step 2, I want you to solve for y. So we're going to solve for y. Now, what would be the very first step for solving for y? If I said, hey, I need you to solve for y right here. Yeah. So the first step right here, A, we put add 1 to both sides. And when I say add 1 to both sides, I mean both sides of the equal sign. So we'll put plus 1 right here and plus 1 right here. So let's see what we have. X plus 1 is simply x plus 1. I really hope Leon watches this. Hope everything works out for you, Leon. We miss you. Hopefully see you tomorrow. 2/3 y. So that's what we have so far. Add 1 to both sides. Here we go. B. The next step to solving for y. What do you guys think? What would I have to do to both sides? Divide? Go ahead. Divide by what? 2/3. That's kind of a difficult thing to do, is to divide by 2/3, right? So what we could do, instead of dividing both sides by 2/3, we're going to multiply both sides by the reciprocal. Move over a little bit. We're going to spell reciprocal. Which is what? What's the reciprocal of 2/3? 3/2. We're going to multiply by the reciprocal of 2/3, which is 3/2. So here we go. We're going to take this side and multiply it by 3/2. Then we're going to take this whole thing right here, this whole x plus 1. Let me slide over a little bit. And multiply this side by 3/2. So what's going to happen on the right side? These will cancel each other out. Because 3/2 times 2/3 is 6/6. And 6/6 is equal to 1. But I have to distribute the 3/2 to both numbers. So here's what you're going to get. Your final answer, everybody, is going to be y equals 3/2x plus 3/2. So I guess I should tell you, you do need to distribute the 3/2 to that x plus 1. Okay, you got to distribute that. Okay? So remember what I said the final answer would look like, everybody? The final answer is going to be f of -1 of x equals 3/2x plus 3/2. What was f of x originally? It was 2/3 x minus 1. These are inverses of each other. These are inverses right here. And we're going to prove it. We're going to prove it because we're going to look at some ordered pairs that they create. Okay, so we're going to get our graphing calculators, and we're going to look at some ordered pairs. I'm going to make ordered pairs with the f of x function, and I'm going to make some ordered pairs with the f of -1 of x. Oh, it's not that bad. It'll be okay. All right, that's a good sign. So, right, go to your graphing calculator. All right, go to your graphing calculator. Whoa, that's a good practice. Let's figure that out. Figure that out. All right. Right now, I'm going to hit y equals. So go to y equals. You're going to type in 2 divided by 3x minus 1. And I'm going to go down to my y. Actually, I'm going to go down to y4 since I use that color. I'm going to do 3 divided by 2x plus 3 divided by 2. I'm going to check the table. Second graph. I'm going to check the table. I'm going to take a picture of this. And I want you guys to look at -1. I want you guys to look at 1. And I want you guys to look at the number 3. So here we go. We're going to look at -1, 1, and 3 for the y-force. Let's go back. So right here, I have -1, 1, and 3. Let's go back and take a look at it. What did -1 go with? -1 went with a 0, right? So -1 went with 0. What did 1 go with? 1 went with a 3. And what did 3 go with? 3 went with 6. Now, I bet, without even looking, I bet the other one's going to have a 0 and a -1, a 3 and a 1, and a 6 and a 3. I bet all the blue coordinates will be 0, -1, 3, 1, and 6 and a 3. Let's see if that works. 0, -1. Hey, look. 0, -1. What else did I say there was going to be? 3 and what? 3 and 1, and then I told you there was going to be a 6 and a 3. So if we go back, do you see how these ordered pairs are inverses of each other? These ordered pairs are inverses of each other. That lets you know that these are, you did find the inverse of the function. So what I want you to do now, I want you to hit zoom forward. These cross each other. But before you guys go, I want you to hit y equals, and I want you to type in y equals x. And hit graph. Do you guys see how these functions reflect across y equals x? All right? So, your final answer, everybody. What was your final answer for f of -1 of x? It was equal to 3 over 2x plus 3 over 2. And that's your final answer.